Hi friends, welcome to follow up. Let's have a look at problem 86, partition list. So this is today's daily challenge problem. So in this video, we're going to present two formats of solutions. So one is based on scan the list and then separate the nodes by values. And the other is to use dummy nodes to effectively do the same thing, right? So here we are given the height of a linked list and a value x. So we want to partition it such that all nodes less than x come before all nodes greater than or equal to x. So here the constraint is that we want to preserve the original relative order of the nodes in each of the two partitions or groups. So here are two examples. In example 2, so we have just two nodes. So we have 1, 2, right? So in example 1, so the ones less than 3 is 1, 2, 2, right? The ones no less or greater than or equal to 3 is 3, 4, and 5. So we want to preserve 4, 3, 5 as in the original linked list. So here the constraints are the following. So the number of nodes in the list is in the range given by this closed interval, and the upper bound is 200. It's not very large. And the node values can be negative, can be 0, and can be positive, but it's bounded by 100 in absolute value. And x is given in this range, right? This means that it's possible that we can return all the original nodes, because if x is very large, for example 200, and then all the node values is smaller than this x, so we just return the original linked list. Or if x is very small, we do the same, right? But that's just some simple observations. So here, as we mentioned, we're going to use two strategies. As the problem logic is very straightforward, so we directly do the coding. So first, I'm going to write one version, so just a naive version. Scan the list, separate the nodes by values. So here, let's use a smaller and larger. So, and then let's do the traversal. Well, height. So what we want to do, let's check the value, height value, right? And then we want to see if value is less than x, so we can smaller append this value, right? Otherwise, so larger append. So here is a comma, append this value. So here we appended the value just to save some space. You can actually append the node as it is, right? Or you can directly do it, but we are going to cover this in the second version. So then we are going to reset the height to be height next, right? And then what we want to do is to connect this together. So for dummy equals list node, so I'm going to use 101 negative because it's smallest. Then what we want to do, here I'm also here. So now let's set a current to be dummy. And then we're going to iterate. So for x in smaller, let's concatenate these two lists. So this will preserve the order, right? And then what we want to do as temp, let's make a list node. So that's the value to be the x. And then we connect current with the temp, and then reset current to be temp, right? Then after this for loop, so we can return the height. So it's dummy next. That's also why we use dummy. This brings some convenience. So with that said, basically we finished one solution format. Before we move to the second one, let's first do a test. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the generic cases very fast. So now let's look at the second solution. So I'm going to copy this part. So I'll change this one to be version v1. And then we basically slightly optimize a little bit. So for this, we just need to use two dummy nodes to connect the nodes with smaller values and the ones with large values, and then we connect them together, right? So we notice that we need to use the tail of the first one, then connect with the header of the larger one. So this is the one point we need to pay attention to. So here let's use a small. So we're going to use small dummy, right? So we're going to be list node. So let's set the value to be negative 101, and then let's use large equals large dummy, right, to be list node. So value is negative 101. So this is just for convenience. So next, let's iterate first to separate the two groups of nodes. So while height, let's say check the value. While height value is less than x, then we're going to connect with the small, right? Small next to be the height, right? And then we're going to set small to be small next, right? So actually we set it to be the height because small next is first reset to be height. So we write it like this just for the uniformity of the forms. So otherwise, so we're going to use large next to be height, and then we reset large to be large next. So this way we finished grouping separate nodes according to values, and then we are going to update the head state, head to be head next, right? So this way actually we get two linked lists. One is small, or you can see started from the dummy index, small dummy, and the other is large dummy, right? So here we use small and large as running variable. We use the small dummy and large dummy as the head. And then after we exit this while loop, so we are going to have the small, the tail. Small will be the tail of the first group of nodes. And then we can do the following thing. So if large, right? So we're going to see large next to be now just to break the connections. And then so this is to eliminate possible cycles. And then let's see if small, what we do, we connect next to be the large dummy next. So this way we connected the two portions of the linked list, and then we're going to return small dummy next. So that's the way, or that's where we use the dummy. So this is as the URL, right? So here the large dummy and the small dummy together, it means that we want to connect the two parts together. So in total, this forms another solution format. So before we do anything, let's do a test first. So let's run it. Yeah, it passes the first example, right? It's the first example here. So now let's test the second one. Just for, so we have 1 and 2, and then 2, 1, and 2. So let's test it. Yeah, it passes the example 2. Now let's look at the generic case. So yeah, it passes the generic cases. So I would say for that's about it for solutions to this specific problem. But here our goal is to practice some tricks like using dummy indices, dummy nodes, and also here we separate the node directly according to the values, and then we connect them together. It's a point that deserves some digest. So if you didn't do a lot of problems related to linked list before. But with that said, that's about it for this video. Thank you.